let's start with the new topics, that's colloids. What is colloids? Colloids is made of two different particles. That's one is dispersed phase, and second is dispersion mediums. Like solution is made of solute and solvent. Here colloid is made of dispersed phase and dispersed mediums. Here solutions is quantity is low than solvent. A solvent is high quantity. In high quantity, here dispersed phase dispersed phase is always in low quantity, and dispersion medium is always in high quantity. Okay, we are will see what is dispersed phase. The phase which is distributed or dispersed the medium is called dispersed phase. Okay, the phase which is distributed or dispersed the medium is called dispersed phase. The phase means the phase which is distributed on the other medium is called dispersed phase. The phase which is distributed or dispersed the medium is called dispersed phase. Okay, what is dispersion mediums? Okay, dispersion mediums is dispersed phase is always in low quantity, means it will disperse on another medium. But what is dispersion medium? A medium in which colloidal particles are dispersed is called continuous phase or dispersion mediums. Okay, means dispersed phase, a medium in which colloidal particles are dispersed, means dispersed phase will be dispersed is called on a medium. That medium is called dispersion mediums. Dispersion medium means a medium in which dispersed phase will be dispersed. Dispersed phase will be dispersed on the medium. That medium is called dispersion mediums. Okay, we will see one example. That example is gold salt. One example is gold salt. What is gold salt? The gold, in this gold salts there are two particles. Like colloids, we have two particles, that's dispersed phase or dispersion mediums. Okay, like that in gold salts also we have gold particles. And another is water. In this gold salt, gold particles are dispersed phase, means this is in always in low quantity, and water is a dispersed mediums. Here dm means dispersion mediums, and here dp means dispersed phase. Okay, sdp is not like that we use in WhatsApp, that's different. Here dp means dispersed phase and dm means dispersion mediums. Okay, gold particles is a deep dispersed phase, and water is a dispersion mediums, and water is here is dispersion medium. Let's see what's the happens if we mix. We have in these beakers we have water. This is the water. In these waters we have put some gold particles. This is the gold particles in yellow. This is the gold particles in yellow colors. This is the gold particles. If we mix gold particles in waters, particle in water, colloids becomes colloids. It will be sometimes it will become colloids. And this is the water solvent, and this is the gold particles, means this is the solute. This is the solute. Okay, if we mix water, if we mix in water gold particles in water, then it becomes the whole solutions. This is the whole solutions become our gold salt. This is the example. This is the best example of colloids. We are seeing right now the classifications of colloids. We will classify on the basis of some basis. Colloids will be classified on the some basis. Okay, we are first seeing the classifications of colloids on the basis of physical state of dispersed phase and dispersed medium. On the basis of physical state of dispersed phase and dispersion mediums. This is the one of the most important part in surface chemistry. Dispersion mediums, dispersed phase, I say already before that's dispersed phase means that's solute and dispersion mediums means solvent. As we compared the colloids in the solutions, if we compared colloid is a solutions, then means this is also always in low quantity, in this is always in high quantity as compared to dispersed phase. Okay, we have to remember this thing. If we take dispersed phase solid, dispersed phase solid, dispersed phase solid and dispersion medium solid, then the colloids will happen like solid colloids. If we mix solid in solid, then it will become solid. This is the common sense. Okay, this becomes solid soul. And the example of solid soul is some color glasses and gemstones. Means if we see the color gemstones are the example of solid soul. Means if we take transparent gemstones and if we are mixing some color gemstones in that, it will become shines. This is the example of solid souls. Okay, and the second types of colloids is, if we take dispersed phase is a solid, and dispersion medium is a liquid. If we mix solid in liquid is in high quantity, air, liquid is in high quantity, as we see. Okay, as we know already that liquid will be in high quantity, air, and solid will be in low quantity as compared to dispersion mediums. Okay, if we mix solid in liquid, the colloid will happen is sol, and this is the example of paints and cell fluids. Third type is we have solid is a dispersed phase and dispersion medium is a gas. And the colloids will happen is aerosols, because gas is in high quantity as compared to dispersed phase, means solid. Gas will be more in this colloids, it will becomes aerosols. And example is smoke and dust particles. If we see fourth example is, we are taking dispersed phase as a liquid, and dispersion medium is a solid. And it will The type of colloids is the gels. Gels. And this is the example of cheese, butter and jellies. The fourth example of classification of colloids is liquid. We are taking dispersive phase as a liquid and dispersion medium as a solid. In this case, liquid as in low quantity as compared to solids, it will go as like physical properties of these colloids will become like a solid, solids. And this case, the types of colloids is gel. This case is the gel, and it will look like some like solid, means we have liquid in this, but we have solids is more as compared to liquid, and this physical properties look like solids. And in this case we have example jellies, butter, cheese. The fifth types of colloids is we have a dispersive phase as a liquid, and dispersion medium is also liquid, means air, liquid, and we have liquid and liquid. We are mixing two liquids in one beaker and colloids will be formed, like we see as a gold salt. This is the example of emulsions. Types of colloids will become emulsions, and this emulsion as example is milk and air cream. Milk has two contents, is becomes water, made of water, and second is a fatty acid, protein, or in many things. Okay, milk is the example of emulsion, and second example is air cream. Okay, fifth types of colloids is sixth types of colloids is we have dispersive phase as a liquid, and dispersion medium as a gas. In this case, gas is more as compared to liquid, low quantity, and it will be physical properties will becomes look like gas. Okay, gas, air, like that. And we have liquid. In gas we are mixing a liquid, and it will be the types of colloids is aerosols. And this is example of aerosols is a fog, mist, cloud, insecticide sprays. In this we have gas. In fog we have gas, and also say liquid. We have liquid. When we feel fog, that times we are if we traveling with cars and there is a fog, that times on the glass of car the fog will settle, and that times we see the liquid look like a liquid plus airs, like air drops plus liquid. This is the example of aerosols. Okay, and seventh types of colloids is the solid sols. In these solid sols we have dispersed phase as a gas, and dispersion medium is a solid. Dispersion medium is always in more quantity as compared to dispersed phase. This is a low quantity. Okay, and this we have solid as a dispersion mediums, means its physical properties will look like a solid. Here is a solid, and it will go become solid soul. An example is foam and rubber. Foam rubber. Okay, example is foam rubber. And 8 types of colloids is a gas as a dispersed phase, and dispersion medium is a liquid. An example and types of colloids is a foam. So colloids is a foam, and example of foam is a froth, whipped cream, and soap leather. This is the 8 types of colloids on the basis of physical state of dispersed phase and dispersion mediums. Here is one trick to remember or understand better. If we have solid as a dispersed phase, solid, then it will show physical property is a solid. Physical property is a here solid. Also here is a solid, and here is also solid. Okay, and if we have a dispersed phase medium is a liquid, it will look like liquid, here is always liquid, here is also liquid. Physical property is a liquid, and here is also the property is liquid. And if we have dispersion medium as a gas, then it will show physical property is a gas. More so the physical property is a gas. The types of colloids is more depend on the dispersion mediums, because this dispersion medium is always high in quantity as compared to dispersed phase. Okay, seeing second difference, the basis of interactions between dispersion phase and dispersion mediums, we have two different types of colloids. One is lipophilic colloids and second is liophobic colloids. What is means of lipophilic colloids and second is liophobic colloids? Lipo means liquid, philic means lipo means liquid, philic means loving, and second here is lipo means liquid and phobic means hating. Lipophilic colloids and liophobic colloids. What is lipophilic colloids? First difference between lipophilic colloids and liophobic colloids is lipophilic means liquid loving. Here also meanings of here is liquid. Lipo means liquid and loving means loving. There is lipophilic means liquid loving. And what is liophobic? Liophobic means lipo means liquid, phobic means hating. Liophobic means liquid hating. It's so simple one. And second difference between lipophilic colloids and liophobic colloids is colloidal solutions in which particle of dispersed phase means solute have great affinity for dispersion mediums. Dispersion mediums means if we have two people love each other, then they will give place in heart. But if here is a means two-sided love, you can say here is two-sided love, and liophobic means one-sided love. For our remember, for tricks to remember. Okay, colloid colloidal solution in which particles of dispersed phase solutes have great affinity for dispersion mediums. And here leophobic colloid means colloidal solution in which the particle of dispersed phase have no affinity for dispersion mediums. Means here is one side low. Here solid is loving on solvent, but solvent is not loving on solute. Solvent is not giving place to solute come together. This is the second difference is leophilic colloids means colloidal solution in which particle of dispersed phase means solute have great affinity for dispersion medium. But here is a colloidal solution in which the particle of dispersed phase have no affinity for dispersion medium. No affinity for dispersion mediums. Example of leophilic colloids is glue, gelatin, starch, protein with suitable liquids. And leophobic colloids have example is solutions of metals, example gold, example silver and gold salts. And fourth difference between leophilic colloids and leophobic colloids is leophilic colloids means it is a reversible sol, means that if dispersion medium is separated from dispersed phase, the sol can be reconstituted by simply mixing of dispersion mediums and dispersed phase. On this concept, in 2010 question asked in CBSE board. This is a important point from exam point of view. It is a reversible sol, means that if dispersion medium is separated from dispersed phase, the sol can be reconstituted. Can be reconstituted by simply mixing of dispersed medium and dispersed phase. And leophilic colloids means it is an irreversible sol. It is an irreversible sol means that it cannot be prepared by just mixing of dispersed phase and dispersed mediums. It can be prepared only by special methods. Means leophobic colloids means it is an irreversible sol means that it cannot be prepared just by mixing of dispersed phase and dispersed mediums. It can be prepared only by special methods. And fifth difference between leophilic colloids and leophobic colloids is in leophilic colloids it is a stable colloid. It cannot be precipitated easily. And leophobic colloids, it can be unstable colloids, so this sol needs stabilizing agent for preservation. This is the fifth difference between leophilic colloids and leophobic colloids. In leophilic colloids, it is a stable colloid. It cannot be precipitated easily, and it doesn't require stabilizing agent for stable because it already have a stable colloids. But in leophobic colloids, it can be unstable colloid. So this sol needs to stabilizing agent for preservation. It needs stabilizing agent to stabilize. Okay, this is the fifth difference between leophilic colloids and leophobic colloids. We are seeing right now third classifications of colloids on the basis of types of particles of dispersed phase. Only with dispersed phase. We are talking only about dispersed phase. The first types of colloids is in the multimolecular colloids. What is multimolecular colloids? Okay. On these solutions, a large number of atoms or molecules of a substance aggregate together to form species having size in the colloidal range. The species are thus forms are called multimolecular colloids. Means in on dissolutions, a large number of atoms or molecules of a substance aggregate together. Means large number of atoms come together aggregate means come together to form species having size in colloidal range. Size of colloidal range ranging between 1 nanometer to 100 nanometer. Okay, the size of species ranging between 1 nanometer to 100 nanometers, and that substance come together and aggregate. Okay, after on these solutions, with these solutions, a large number of atoms or molecules of a substance aggregate together to form species having size in colloidal range. The species are thus forms are called multimolecular colloids. And second type is macromolecular colloids. Macromolecular colloids polymer in suitable solvent from solution in which the size of micromolecules may be in colloidal range. Means it will maybe, the word is used is maybe in colloidal range. Such systems are called macromolecular colloids. Example is polymers like starch, cellulose, protein, enzymes, and polythene. Micromolecular in suitable solvent from solution in which the size of micromolecules may be in a colloidal range. Such systems are called molecular colloids. Here, word used is a maybe. It will be or not in colloidal range. Maybe in colloidal range. And third is associated colloids. These are some substances which at low concentrations behave as a normal strong electrolyte, but at higher concentrations exhibit colloidal behavior due to formations of aggregates. On low concentrations, means if we pass current, it will pass, but on higher concentrations electric current will not pass from these solutions. Associated colloids, these are some substances which at low concentrations behave as a normal strong electrolyte but at higher concentrations exhibit colloidal behavior due to formations of aggregates. And our second point in associated colloids is the aggregate particles are called micelles or associated colloids. The aggregate particles, okay, after higher concentrations exhibit colloidal behavior due to formations of aggregate. These formations of this aggregate particle are called micelles or associated colloids. And third point in associated colloids is the formations of micelles take place only above particular temperatures. That temperature will be called Kraft temperature, and above a particular concentrations called CMC means critical micelle concentrations. An example of associated colloids is soaps and detergents. Soap and detergents. We will some revise the what is multimolecular colloids. On these solutions, a large number of atoms or molecules of a substance aggregate together to form species having size in colloidal range. This is the important. In multimolecular colloids, a large number of atoms or molecules of a substance aggregate together to form species having size in colloidal range. These species are called multimolecular colloids. An example of multimolecular colloids is a gold sol and sulfur S2 sol. And second type of colloids is macromolecular colloids. In these colloids, macromolecular in suitable solvent from solution in which size of macromolecules may be in a colloidal range. This is the important, may be in colloidal range. Such systems are called macromolecular colloids. An example of macromolecular colloids is polymers like starch, cellulose, protein, enzyme, polythene, etc. And third types of colloids is associated colloids. These are some substances which at low pressures bear as normal strong electrolyte. Means if we pass electric current from these solutions or from these colloids at a low concentrations, the current will pass from that colloids. But at higher concentrations exhibit colloidal behavior due to formations of aggregates. But at higher concentrations, if we pass electric current, it will don't pass current from these solutions or colloids. This is called associated colloids. Second point of associated colloids is the aggregate particles are called micelles or associated colloids. And third point in associated colloids is the formations of micelle take place only above a particular temperatures at that temperature called Kraft temperature Tk, and above particular concentrations called CMC means critical micelle concentrations. Critical micelle concentrations. And example of associated colloids is soaps and detergent.